Hallo? Ja, så sker der noget. Awesome, and thank you for joining me here for the first presentation of this Bornhack. So I'll try to give a little sort of look into the badges that we've been doing for the past 5 years in here at Bornhack, and go in a little deeper on this year's badge, what's on it, some of the production stuff of what happened, and the little nitty-gritty nerdy things. So first, go through all the little history of badges we have here. We have sort of a mini sort of anniversary with the 5th edition of Bornhack, and then look into some of the ideas and the plans for the badge of this year, and then what actually ended up being in the badge for this year, and then close up with a look at how badges like these are made. Also, due to the how it ended up being made, there's a little more information that you normally would get in production. So the mini history, most of the badges we have had has been sort of focused on being relatively simple, so that most people, if they sort of wanted to figure out and sort of understand how the badge works, they could go in and look at it, and it wouldn't be like too complicated. It would be simple things connected to each other, and tried to put it in sort of in a way where it could be understood and sort of fairly deep, because many of these electronics things, they are, for some, they are just a black box, and there's something you use, you put some software in, and something comes out. But on the level of these batches, you can actually go in and actually figure out the whole thing, and how stuff is on the little nitty gritty things, on little registers, and so on. That's possible on many of these, and not an undoable task. Another thing is that these batches shouldn't be too expensive. We are still sort of a smaller hacker camp. We need sponsors to pay for some of these things, and we don't have like an unlimited budget to play with. So trying to sort of keep them within a reason, so we don't spend like all the ticket money on just a batch. We also need like toilets and all the other things, and speakers tent and so on. So they need to be manageable in price. And one of the things that we've been using, especially for the past this year and the past 3 years, where sort of we can write software on the batch. We've been sort of inspired by the demo scene thing, where we have like a limited set of resources. You have like 8K or 128K or whatever sort of limited stuff you can put in, and there's like a border. You can't expand that. It's what's there, and then do the best we can with that. That's been sort of one of the ideas, and having these fairly small processors, fairly small microcontrollers. They're still 32-bit and so on, but they're still in the small range. We are normally measuring flash in kilobytes and so on, not in megabytes. So the first batch of Bornhack was very simple. It was there was no microcontroller on there. There was just a used battery and then a few normal electronic components. It's a little circuit known as dual thief, where you can boost the voltage of a used AA battery that's usually on the 0.8 volts, maybe 0.5 if it's really used. You can boost that voltage up enough to light up a little LED. You can use it as a flashlight in your tent, or you can. That was sort of the first batch. It was very cheap to make. It was very quick to make because I had made similar circuit before. So it was actually sort of a surprise thing. Nobody actually knew there would be a batch except for me and a few others. So that was sort of a fun thing there. It was mostly a soldering exercise. People had to solder it themselves. It's fairly easy, but if you're not used to it, and don't, it's a little sort of new experience in that area. There was some sort of prototyping area on the batch, but only like I think a few, maybe 1 or 2 people actually sort of took advantage of that. It looked like this. We used the logo from with Bornholm Island as the main feature on it, and then there was a little LED that you could point in different directions, and it could either be on your name or something. So it also had the name tag feature on the badge. Even the little coil, you had to wind that yourself, so it was like a really DIY project. For the 2017 batch, we went to a microcontroller-based platform. It's the same that we've been using for a few years now. One of the main features we put on this one was that Esmil, he wrote an awesome bootloader that made programming this batch much easier than many other electronics. You didn't need extra programming circuit to do it. It was just a USB plug-in, shows up mass storage, write your files down to there, and then you're going and had a new firmware on it. We had a little OLED LED screen on it, and the production of this batch was the sweatshop style in Labitat. We thought, yeah, we can make 100 and 200-ish batches. We can do that by ourselves. Time was a little limited. We tried it, and we also succeeded. Everybody got a batch, but it's a lot of work, and when you haven't done this before, it takes some practice to put the stencil correctly, and when it gets smudges, you have to fix stuff afterwards. This is how the batch looked. It had a little 128 by 64, I think, OLED screen. Had 4 buttons for navigation. Somebody wrote a little snake game, I think. There was some star field animation stuff. There was some physics animation where the dual pendulum stuff. So people managed to go in and hack that and write some code on it. This was all C-based, but it was fun to see people actually digging in, and the software angle is sort of, I think many people here will have somewhat ease of getting into that. So for 2018, we need to do more and other things. So this was had a focus on the radio communication. We looked at the BBC microbits, and they have a Bluetooth low energy on there. And that was sort of the circuit that we sort of took and put on the badge here, in combination with the Happy Gecko that we had from the previous year. Esme wrote a bootloader that could flash the Bluetooth Cortex M0 via the USB, the same controller, and so on. There was no screen on this badge. You could add one yourself if you wanted to, but some people seems to the very limited UI might have been sort of hindering in making quick hacks and getting something to blinking. These badges were assembled in China. That was the first ones we had where we just got fully assembled PCBs with surface mount components on there. It went very smooth. It was actually the PCB Way that was the sponsor for this badge. They actually contacted us and said, okay, we can help with doing that. And they actually did a great job. Even in a somewhat limited time, they actually managed to get the badges out to us in good time. So the battery holders were sorted on by some volunteers at the camp. Very awesome. But that was the only sort of post receiving them production we had to do, and that was sort of a nice flow. So the antenna for the Bluetooth actually goes up in the little antenna on the badge. It's just a tiny trace, and it seems to work fairly okay. I think some of the Ponies guys had communication between two tents and so on. So that was fun. Same bootloader as the one used for them for the previous year. And then last year, the screen thing seems to be a topic people like. So we put a 240 by 240 pixel full color LEDs TFT IPS screen on it. It had a lot of pixels, so we also kind of had to put an SD card on because the little Happy Gecko has very little limited memory. So if you want to actually have images on the screen, you need to store them somewhere. We kept with the same controller and started experimenting with infrared communications to sort of have some batch-to-batch communication. I needed to, I should have looked more into that because it worked really bad. It was like this much distance you could communicate on, otherwise it wouldn't really sort of receive the data correctly. These batches were also assembled in China, but I kind of screwed up a few things, and those things had to be fixed when we received the batches. So the production went actually pretty nicely, but the work afterwards was a lot of work. There was a whole group of volunteers, mostly from Holland and UK, that did a great job in having this sweatshop on site and fixing, I think, a total of 400 batches. That was an awesome job there. But ideally, we shouldn't have that sort of things on site. This was the badge shaped as the Yoda lightsaber in the Star Wars theme. All the main components are sort of hidden behind the screen. So now we're moving to this year's badge, taking some of the experiences from the previous batch productions and so on, and how people use them, and trying to figure out, okay, what would be nice to have on a batch. Some of things were like something that resembles a screen, something you can see, something, put text on it, put graphics, put blinky stuff. That would be nice to have. And also, right now, this whole spring and summer, it's been a little different, I guess, for most people, and maybe trying to see if we can get some of that into the batch also. That would be fun. And the plan is to have as much as this batch machine produced, so that we don't have to have these sweatshops and doing a lot of assembly afterwards. And then having it really easy to get started with just jumping in, writing some code, that sort of process should be as easy as possible to get as most people to hack on the batch and do their own little designs and customize the batch to their own liking. Originally, we went with RISC-V processor, and we found this GD32VF103. It's a clone of, it's a variant of a clone they did of an ST chip in a factory in China. And it looks pretty good. You can get some dev kits from Seed Studio, and I have also managed to actually get some chips, loose chips. It was via Taobao and Superbuy in China, and it was a little hassle and took a while. But we actually managed to get a little dev kit and put something together, and Esmil have wrote a bunch of code to it and actually made it pretty neat. But getting these chips, when I called the factory and said, oh, we need to get these chips, and if they could help source them, and the answer was just no, they couldn't. So making a batch and having it assembled in China without being able to get the chip was a little too much for, at least for me this year. So we ended up doing a setup with a SAMD21. It's a chip I've been playing a little with before, so and getting the chip is just like asking DigiKey or something similar to just ship it, and you have it 2 days later. That's sort of a little easier to get your hands on. And then we've gone with CircuitPython on the chip, because this chip there's already sort of support for the CircuitPython on the chip. There are many other dev boards that already use this chip and CircuitPython. The chip is very similar to the Happy Gecko. It has the same sort of USB interface built in, has crystal-less operation, so you don't need external crystals, keeping the component count down on the batch a little bit. The other sort of the main feature on this batch is a lot of LEDs. So you can do either blinky or you can do text. You can use it as a screen. It's only like 9 pixels by 32 pixels, which is of course a limitation, but that's sort of back to the demo scene thing, where having a limited scope, I think many of you will be able to do awesome and very interesting stuff with this setup. All the LEDs are driven by 2 LED controllers. Each of the LED controllers takes sort of half of the batch. So 144 LEDs in one half of it, and the other 144 in the other half. They are controlled via I2C. They have 2 different addresses, so they're on the same bus. But in the CircuitPython code, you can have them as either you can have them at two displays, and then you can sort of, with a frame buffer, you can do some little fiddly, so it works as one large screen. These little chips can actually store 8 frames in the chip. So if you have like a simple animation, you can have these 8 frames stored, and you just need to sort of flip which frame is displayed, and the chip will do that. So that's one way of offloading some of the load of the main processor if you want to do other weird stuff or infrared or something, playing with that. So that's sort of the next thing is take 2 on the infrared. Hopefully getting this to work on longer distance than these tiny little ones. So we have an infrared LED that can emit signals. That is this year driven by a transistor, so you can have the current going through the LED way higher. It's not that much higher, but it's more than what the pin on the controller can handle. And the receiver side is a complete module that has ambient light compensation, so that they will likely work both indoor and outdoor-ish. And also it has the decoding of these 38K signals that normally used with infrared at receivers and transmitters. So they should also work with many little remotes that you have for TVs or whatever stuff you use IR for. And similar to many of the previous batches, we have this little gaming thing, because I think on a screen this size, on a little handheld device, some sort of games, I guess, is an obvious thing to put on there. I would really like to see Tetris running on this curved display going down, and it could be a fun thing to see that running. These are directly connected to the pins on the microcontroller, so you can do normal. It should be fairly easy to use. So to boost the flash that is on the microcontroller directly, we've added a little 4 megabytes SPI flash. That's enough to keep a bunch of CircuitPython libraries. You can have maybe a little graphic files. There's on the batch right now. There's a little font, bitmap font loaded on there also. And when you plug the batch in, this 4 megabytes SPI flash will show up as your mass storage device, and that's where you save the files. That's also where the code.py file is located. Of course, the 4 megabytes is small compared to the SD card sizes that you normally would use, but with the screen size on this batch, I don't think you will need like gigabytes of flash storage. One other change we did this year is we went with a USB-C connector. I think many mobile phones and computers have sort of been moving towards that, and these connectors have been sort of going down in price. This is a limited pin count connector, so we don't have the high-speed connections that is used for USB 3 and so on, but the controller can't handle that in any way. But the SBU 1 and 2, that's the sideband use pins that are in the connector. Those are actually connected to the chip. So if you want to have like a batch-to-batch wired communication, a fully populated USB-C cable should be able to hook those two up. So if you run like a UART, RX, TX stuff, if you get it mixed up, you can just flip the USB-C connector on one end, and you can just rotate it, and it should be flipping the RX and TX, because one SBU is like symmetrically on the connector. You can also power the batch similar to the previous years on the USB connector. It has a voltage regulator pulling the voltage down to 3.3 volts, and that the whole batch runs on that. The batteries, they have a boost, so they boost the voltage up to 3.3, mostly because the SAMD, when running in the CircuitPython setup, it has a brownout levels fairly high, and when the LED sort of starts blinking a little, they pull a bit of current, and then if we hit the brownout, the batch will just restart, and it won't go into the normal run mode. It will go into the brownout mode, so you can fix your code, and then you can sort of go back in. But if I just run the batteries directly in, you will hit that all the time. So this voltage boost was needed. And also we added a physical switch you can turn the batch on and off. It's only turning the batteries on and off, so we have USB connected. It will always be powered. But the battery you can disconnect with the switch, and it's sort of put a little bit inside, so you shouldn't sort of dangle and accidentally turn it on. The batches come with a UF2 bootloader. That's the bootloader that is normally used along with CircuitPython. If you double-click or click twice on the reset button when you have it connected to USB, it should show up as BH batch boot. And that's where you can drop in files if you want to update your CircuitPython and so on, or if you want to put other things on there, write C code or something like that. CircuitPython is preloaded on the batch. When you're in this mode, if you accidentally go into there, the little status LED next to the main controller, that will fade sort of slowly in and out. So if you see that, that's likely because you have clicked reset a little too quickly or something. CircuitPython is Adafruit's version of Python, and it's sort of a modified MicroPython, sort of slightly deviated from the standard MicroPython. It has a setup where when you edit a file and just say save on the device, it will automatically reload the running program and run your code again, which makes for a really quick sort of development, see what's going on cycle. So having this sort of software-like development setup is, I think, is really neat for hardware hardware projects. And it should help anybody also, especially people who haven't coded electronics before, to get in and modify their batch a little bit on the software side. It's just, yeah, edit CodePy and save the file, and you'll have a new text running on the little marquee thing. So there are some things that hasn't been done yet. It's planned to be done, but it will be done sort of over time. It's not super critical for this event right now, but the USB vendor IDs and product IDs, right now they're just sort of stolen from some other project. But to get them into CircuitPython and have CircuitPython sort of maintain hand the badge in there officially, they will need to be like official vendor IDs, and I'll get that done eventually, so that if when it gets up there and it's part of CircuitPython, it'll be correct. When you guys want to update your badge, you can just get a new CircuitPython down there, and it'll update. All could be done via USB. You don't need a programmer for that. So the plan for this badge with like a lot of LEDs, that was to have it pick and placed. So it was like with these many LEDs, you don't want to do it hand. I did the prototypes by hand because I didn't have a pick and place machine, and just placing the LEDs, not all the other parts, just the LEDs takes 40 minutes. If you sort of, I think I know what I'm doing and had it prepped, but it's still 40 minutes for one batch. That's not fun. So if you start calculating out 40 minutes, you need the other components, that may be 20 minutes more. Then it's an hour per batch with 200 batches. Okay, that ends up being 200 hours. That's more than a month of work. That's not what time we have. So the plan was to do production in China. That didn't really happen because stuff didn't work. So the infrared stuff, the booting up where the batch sort of started resetting when the LED controller started up and so on, that's sort of when we were supposed to start production, that was sort of what was happening. So backup solution ended up being that I have a friend with a pick and place machine. That's a good friend to have, especially if he does picking electronic projects. So I asked him, and he said that he would be willing to help out with populating all these batches and sorting them and so on. So for the rest of this talk, I'll talk a little bit about sort of how these pick and place stuff. A couple of weeks ago, I was sort of thinking maybe I should have a pick and place machine, but after actually using one and doing a project like this, I'm not sure I want the pick and place machine because they need to be babysitting. You need to be babysitting these machines, and you actually, if you want to have something that does like fast production, you need like a really expensive machine, and if you have a really expensive machine, you would need to have a lot of stuff going through that machine, otherwise you wouldn't ever pay it back. So yeah, having your own pick and place machine, I don't think that's, unless you really sort of need it, I don't think so. The machine we used here has 4 heads, so it can pick up 4 components at the same time, and then go in and place these components. So to optimize the speed of production, how fast these batches could be produced, because even with a pick and place machine, starting to calculate, okay, how many hours should this machine be running to assemble these batches, it ends up being like 20 hours, and we don't like just have infinite time. So we spent most of 2 days and a lot of 2 nights to get these up and running. But placing these sort of which head places which components in a somewhat optimized way can help reduce the time it takes to place the parts. And also the feeders that the parts come in on, having those sort of placed in a neat way, especially when we have these 288 LEDs that need to be placed, and the other components are sort of low count. We actually had 2 feeders feeding these LEDs so that they could move quicker and pick them up, and we didn't have to replace reels as often as we would if it only one reel there. So let's see if it works. Yeah, so this is the machine picking up 2 parts in 2 reels, checking with the vision that the parts are actually on the feeders, and then placing them on the batch. And then you see one head has this section, the next head has the next section. So the movement of the head is the minimal amount of movement that we could sort of come up with. But getting to that point needs a little tweaking, because which head is number one, how is the batch rotated and so on in the machine, and all these little things. That takes time, and that's sort of the setup time of a pick and place machine, getting the feeders put on with the reels you have you purchased, and positioning the machine, telling the machine which sort of feeder is which component, and where the nozzle, which nozzle should pick up in which feeder. All these little things is a planning process that if you send them to China, they will handle that. But if you want to optimize for cost or speed or something like that, then when you design your projects, having some of these things in mind might actually save you a bit of money or time, even if you don't do the production yourself. The software for this machine is, it's a Chinese machine. Most of this is actually in English, but the dialog boxes are usually in Chinese. So you kind of have to know what it means, or that's what they want, because you can't read it. Not all of the process is automated. My friend doesn't have like an automated paste dispenser, for instance. So the first process in the PCB is putting the PCB in this little jig that I've put together, mostly with tape and 3D printed parts. And then squeegee on the paste. That's the little solder that holds all the components to the board. Getting this job right is kind of important, because if you have them smudged and sort of touching each other, then you will have to fix stuff later on. And some of the batches, quite a lot of them, especially the small parts, the LED controllers, the solder paste got so close and smudged that most of the batches had to be fixed afterwards by hand. Another issue is that some of the LEDs, like the one in the corner up here, the machine put it on the side, so it doesn't really shine up. I think we catched most of them, but there might be a few that we've missed. But this manual step of looking through a microscope and checking all the parts that are on there, and then adding the leftover parts, like connectors and the controllers, they're all placed by hand by me and my friend. So it was like a tedious job, and it ended up taking at least 2 days and most of the nights also. I put up all the files on the GitHub repo. I see already people have been doing pull requests, issues, and that's awesome. I'll get to them and look at them, and you're very welcome to do pull requests. If you have like an awesome project, you write some code that can go on there, very welcome to do it and sharing it via this repo. I'll try to be as quick as possible to get it put in there. Any questions? Yeah.
Why not flash LEDs for 4 feeders?
So all the feeders are used to put the LEDs on there. Okay. So it picks up. You could put 4 feeders in there, but we also needed to. We had a limited amount of 8mm feeders. So if you want to, if you took an extra feeder for an LED, we would have to manually place a resistor instead. So it was sort of weighing out which sort of work. And also halfway during this, the nozzle free stopped sucking up the air to pick up the components. So we had to sort of decommission feeder free, the nozzle free, and then only having 3 feeders. That changed the sort of time to populate a board from 6 minutes to 7.5 minutes. So that's just so even with the same parts, the same population, it's 25% extra time just because the feeders are different. Any other questions? Otherwise, feel free to sort of ask me during camp. I'll be here all the time. And I have a little mini electronics lab sitting down in one of the workshop rooms. So if one of you, if you want to sort of see a little bit more, we can maybe do a little session and hang out down there. I have a little microscope also. We can inspect the PCBs, see if they are properly fixed. Cool. I hope you guys have fun with the badge and do some interesting projects.